to video 3 of section 7.1, sequences. So here's the other way that we sometimes write a sequence, is by using these curly brackets, and then we would have our definition of our sequence in here, whatever a sub n is equal to, and then we would use some notation to indicate the end value and the starting value. So down at the bottom here would be n equals, and it would tell us a number that would give us the starting value for our sequence. And then up here we would have like the end value, or if it doesn't end, it would just be infinity. Okay, we're not actually going to use that notation. Well, here's an example. Here's an example of that particular notation if you want one. So if we had something like f of n equals 2n minus 5, where n equals 1, 2, 3, etc., then we can also write that as 2n minus 5, and we can say n equals 1 to infinity. That gives us the sequence. Explicit formula tells us where to start and where to end. So just kind of a little notation that's going to be helpful when we get to section 7.2. Okay, so you see some examples here. They're not using that notation we just talked about. This is more like the notation we've been dealing with already. So we're going to find the first 4 terms by plugging in 1, 2, 3, and 4. So there you go. F of 1 is negative 3 times 1 plus 11. So that's negative 3 plus 11, which is 8. And F of 2 would be like negative 3 times 2, which is negative 6 plus 11, which is 5, right? And then F of 3, which would be negative 3 times 3 plus 11, so negative 9 plus 11, which is 2. I don't know if you've noticed, but our numbers are dropping by 3, and interestingly enough, we have this negative 3 at the beginning. Kind of like slope in a y equals mx plus b formula. Coincidence? I think not. How would we find the 4th number? We could just subtract 3 now that we know the pattern and know that that's the slope and how much we're decreasing. Or in this case, we're not going to call it slope, we're going to call it the common difference, but we're not quite to that point yet. I'm just kind of prepping you ahead for these vocabulary words you're going to see here. So we get negative 12 plus 11 is negative 1. Sure enough, it dropped by 3. Okay, so that's an arithmetic sequence, right? This next one has an exponent. It's going to be a geometric sequence. Let's watch and see what happens. So we have a sub 1 is 8, and then we're going to use our other n values to find the first 4 terms. So I found the first term. There it is. I just need to plug in stuff to find the ones after that. Pretty easy. So a sub 2 is going to be found by taking a sub 1, which is 8, and multiply by 1/2 to the 2 minus 2 power is what it's telling me to do. So that would be to a 0 power. So 1/2 to a 0 power is 1. And so this whole thing will be 1 times 8, which is 8 again. That's interesting. First 2 terms are 8 so far. This is an interesting sequence. It's not quite a geometric sequence, but it's got some similarities. So this is going to be 1/2 to the 3 minus 2 power. So that will be to the first power. So 8 times 1/2 is 4. And then we have the 4th number, which would be, we now put the 4 there, right? Because we're doing n minus 1. We're taking the previous number. I thought I messed up for a second because I was just using 8, which was the first number, but it was also the second number. So I didn't mess that up too badly. And then this 4, it was just a mess up in thinking, not in how it looked when I wrote it down. So 4 times 1/2 to the 4 minus 2 power. So that's going to be to the second power. That means we're going to be doing 4 times 1/2 squared, and 1/2 squared is 1/4. So that's going to give us 1. Well, there's our first 4 terms. 8, 8, 4, 1. If you want to keep going, this is a very interesting pattern for which I do not have a name. But our whole purpose here was in learning how to just follow a formula and get some numbers out of that. Okay, we can also graph sequences, but when we graph them, instead of connecting dots, we're going to have isolated points that we don't connect. So rather than a connected line, no connected line, just dots. Each point is represented by a coordinate, with the first coordinate, which we normally would call the x value, but we're just going to say it's n. So n is now our x, and a sub n is our y. We're going to just graph those dots. So let's find some values here for our function based on this formula. So plug in a 1, 2 times 1 is 2, minus 5 is negative 3. So I plugged in 1 and I got out negative 3, right? So then I can plug in 2, 4 minus 5 is negative 1. And then plug in 3, 3 times 2 is 6, minus 1 is 1. Plug in 4, 4 times 2 is 8, minus 5 is 3. Plug in 5, 2 times 5 is 10, minus 5 is 5. So plug in 5, get out 5. So to graph this sequence, I would just graph these points. Alright, so now I'm going to go ahead and graph these points. 1, negative 3, 2, negative 1, 3, 1, 4, 3, 5, 5. So you can see I've got a straight line of dots because this type of sequence is arithmetic. It's much like a linear equation. You notice you've got your y equals mx plus b, like your slope, and your y-intercept. But you don't really have a y-intercept because it doesn't go that far. It starts at n equals 1. All of our numbers are in quadrant 1 and 4 because n never is 0 or below. It's just our counting numbers. Alright, these next two problems look kind of intimidating because they have that notation I was telling you about. But don't be afraid, we're just going to use n equals 1, 2, 3, 4, plug them in. So we have negative 1 to the 1 plus 1, because n is 1 power. So that just is negative 1 to the second power. So that's a positive 1. That does nothing to this problem. So now we have this part that's being multiplied in here. So we'll have 1 over 1 plus 1. So it's just basically 1 times 1/2, which is 1/2. So the point we'll graph is n equals 1, and the sequence value is 1/2. So over 1 up 1/2. Okay, let's try the next one. So that would be negative 1 to the 2 plus 1 power, so to the third power. That's going to cause it to be negative. So then n is 2, so that's going to be 2 over 2 plus 1, which is 3. So that would be negative 2/3. Then the next one, oh, I think this is a sequence we saw earlier. Remember that? That's going to be like to the 4th power, and then 3 over 4, and then negative 1 to the 5th power, and then we'll have 4 over 5, so negative 4/5. Alright, so we have the point 1, 1/2, 2, negative 2/3, 3, 3/4, 4, negative 4/5. So we'd graph over 2, down 2/3, over 3, up 3/4, over 4, down 4/5. So kind of this weird little bouncy above and below the x-axis type of pattern. Alright, one more. So n equals 1, so we'll have 5 over 3 to the 1 minus 1 power, so that's 0, so it's 5 over 1, which is 5. And then we'll have 5 over 3 to the first power, because it would be 2 minus 1. So that would give us just 5/3. And then we would be multiplying by 3 each time, so then we would get to the third would be 3 minus 1, which is 2, so squared, so the next one would be 5/9, and then the next one would be 5/27, I think. So to graph that, we have the point 1, 5, and and the 0.25 and the 0.359 and the 0.4527. So that's just going to be like 1, 5, 1, 2, 3, 4, 5. 5/3 will be a little over 2, no, a little over 1, almost 2. And then 3/5 is less than 1, and it's just going to kind of get smaller. So we've got this curved graph, like an exponential curve.